Welcome everybody. Today I want to make a video about the Pshufb instruction. It's a packed shuffle bytes. This instruction is extremely cool. It's very handy. It enables you to do multiple things that you need to do in order to do SIMD instructions, and it's actually quite simple. So hopefully by the end of this video you will have a thorough understanding of this instruction and feel confident and be able to use it. Essentially what it's going to be able to do is let you take any one of the 16 bytes or all of the 16 bytes in an XMM register and move them around to different positions in any way imaginable. You can reverse them, you can do shift right, shift left, you can duplicate one. It lets you, it's kind of like it's multiple instructions all in one. And that's what's so neat about it. And it's really not that difficult to do. So what I'm going to do to get started is I'm going to do some examples, and I think that's kind of the easiest way I like to learn, is just go through some examples and just put some information in and just see what happens. So the first one I want to do, maybe we'll call it test 1. It's going to be a simple function test 1. So let's say you want to take a byte, take a value, and you want to duplicate it across every single byte in an XMM register. For example, one of my last videos, we needed to I think it was 60. 60 was a magic byte that I think it used for uppercasing. I think it's an ASCII character for maybe a lowercase a. So anyway, part of that video had to do with putting that into a buffer in the value 60 in all 16 positions of an XMM register. So when I move that into RAX, it's going to zero out all of the register except for the one at the far right, and it's going to put a 60 in there. What I want to do now is I want to move that into an XMM register. So I'm going to use the move Q. I think I'll move it into XMM 0. It'll be RX. Okay, so now that will be the data buffer. Now I need okay, what I'm going to do is I'm going to go ahead and copy that into XMM1. I'm just going to make a copy for, that's like a visual aid. Now we're going to use XMM2 to be the control register. And the control register has all the magic that kind of tells the shuffle instruction what to do. The control register isn't the data. It doesn't get changed. It's XMM1 that we're going to be changing today. So I want to make sure, what I want to do is I just want to do a EXOR XMM2, comma XMM2. And this is, what this should do is make sure that XMM2 is full of zeros, because that's the control we're going to use today, is 16 zeros. It's the simplest control I could think of to get a nice example going here. So here's the instruction. Pshufb. The register we're going to be changing is XMM1, and the control register is going to be XMM2. And that's it. That's our test function. Okay, we're going to go into the debugger and take a look at this and just see what the magic is all about. Okay, I guess we're not going to go to the debugger yet. I got ahead of myself and I forgot to compile it, and then I had a compile error, and people probably saw that. I put a comma there. Let's try to compile that again. Much better. Okay, now we're going to the debugger. Okay, here we are. We're in the debugger, and I've got it set up on the line we're going to be looking at. You can see we're on the line move R60 into RAX. I'm going to execute that line. Okay, you look over here on the right, you can see the RAX register has the number 60 in it, and it's our debugger makes it nice and red so you can see it's what's been changed. Now we're going to move RAX into the XMM0 register. Let's drag this down to our XMM registers. There they are. And step into that one. Boom, there it is. So we now have one value in 1 byte on the right side. So now what we're going to do is just going to make a copy of the XMM0 register into XMM1. The only reason I'm doing that is for visual aid. That's not a necessary step. Now I'm going to clear out XMM2. You notice XMM2 is already full of zeros. This just makes sure it's full of zeros. So when I execute this step, you don't really see anything happening. But if there was data in XMM2, it would have been zeroed out. So now we're just going to execute the shuffle instruction. The first parameter is XMM1. That's going to be the input data and the output data. So it's going to read from XMM1 and change XMM1, which that's all I got to say about that. XMM2 is going to be the control register. That's the directions that's going to be used, the instructions on how XMM1 will be changed. And I'm just going to run this and we'll talk about what happens. So when I run that, you see that XMM1 is now full of 60s. So what happened? Here's what happened. This first byte here on the right is the 0th byte. They're numbered 0 through F going that way, going from right to left. So 60 is the 0th byte. And when you have zeros in all these positions, it literally tells, in XMM2, it literally tells the shuffle instruction will copy the data that's in the 0th byte into the corresponding position in XMM1. So since XMM2 is full of zeros, it copied byte number 60 into all of the positions. And that is it. That's the simplicity of it, and that is the beauty of it. It's actually a very simple and powerful instruction, and you can use your imagination right now to imagine what numbers you could put in XMM2 to get a whole variety of results. And that's why I like this instruction so much. So let's go back and do another example. Okay, the next example is a real world example of something I was trying to do last week. I was trying to write a base 64 decode using SIMD instructions. And I got to a point where I wanted to shift all of the bytes in an XMM register to the right one position. And I was looking for the magic unicorn instruction to do that. And eventually, on Stack Overflow, somebody said the Pshufb instruction is what you need to do that. And that's why I investigated this instruction. So the example we're going to do next is to shift all the bytes to the right one. So I'm just going to comment out test 1 there. Then we're going to invoke test 2. Shift right. Function test 2 shift right. I really struggle writing the word function sometimes, don't I? Okay, so you may have noticed that I have another line of code that I've pasted in here that I didn't type on the video. This is going to be my magic control for the shift right. So again, this may seem kind of difficult to look at when you're not in the debugger. So first thing you got to realize is that when the bytes are in memory, and then when they get moved into a register, they get flipped over. It's kind of a reverse copying procedure. So what this 01 here looks like it's on the left. When it's in the register, it's going to be on the far right. So, and this 080 looks like it's on the far right. It's in the register, it's going to be on the far left. And by the way, 080, what is that? That isn't 0 through F, is it? So that's your magic number that you put in there that will put a 0 in that position. Just FYI. So I'm not going to ramble through that until we get to the debugger, and then it's so much easier just to look at it, the results, and it makes a lot of sense. So let's just do this. Test shift right. So what I need is some data, and I'm going to type in let's not make it a local, because I'll probably use the same data again and again. Let's make a public aligned with properties DB, and I'm gonna do this quicker. Okay, there it is. I typed it off video. That's gonna be my data, and to me it makes sense. I put the A in there just to make it not look like it's a control. And just go down here and we'll start typing this. So what we want to do is I want to do the same thing. I want to move the data into XML. So I'm going to use the move DQA. The difference between A and U at the end is A means it's aligned data, U means it's unaligned data. I tried to do some testing on aligned versus unaligned. Last week I was doing some testing on it, and it seemed like aligned was faster, but I had some erroneous results where my tests were getting negative numbers and different things were happening where I couldn't really prove that it's faster. So anyway, onward and upward. So what I want to move into XMM0 is my data. So I'm going to do a memory calculation of my data dot address. Now, again, I'm going to, as far as this DQU, DQA, let's try A this time. It really shouldn't matter. I'm going to move into XMM1, XMM0. I'm going to make a copy just for a visual aid. Now, the shuffle register is going to be XMM2 again, and I'm going to move DQA, don't put a comma there this time, XMM2, and I'm going to put in there, not my date, I'm going to put in Pshufb XMM SR SHR by 1. So, I guess I made up my own complicated license plate. I didn't mean to make it complicated. I was trying to make it reasonable. But that's the name of my control data. And to me that means shift right by 1 position. Okay, so the last thing to do would be to issue the shuffle instruction on XMM1 using XMM2 as the control, and that is our test. Okay, so before I say let's go to the debugger, let's try to compile it. Okay, go to compile. All right, let's go to the debugger. Okay, here we are. We're all lined up, ready to go. Here's our lines of code. Let's execute the first one. Okay, XMM0 there on the right in the red line has all of our data. And it looks all jumbled, sorry. It's my sample data. What it does is it has the index is kind of embedded in there. with an A in the front. So 0A is 0. The next one is A1, A2, A3, A4, A5, A6, A7, A8, A9, AA, AB, AC, AD, AE, AF. So I put the A in there just so it didn't look like it was control data. It's actually data, if that makes any sense. So now we're going to make, the next line of execution, we'll make a copy of the data for visual aids. Now we have 2 copies. And the next line, we'll load into XMM2 our control. There's our control. That will be the shuffling that's required to make a shift right, is what we're going for. And if you compare that with what was on my compiler screen, you do notice that it did flip over. The 1 was on the far left, and now it's on the far right. Now it's to execute the shuffle instruction. And again, XMM1 is the input data and the output data. XMM2 is the shuffle control. When that executes, you see, because now that you have XMM0 there, you can see the before and after. You can see that on the far left there's 0, and everything got shifted to the right 1 byte, and the 0A disappeared. That's the shift right. And I think that's just beautiful. It's a way to do a shift right. All I got to do is save my control data as like a constant or maybe a variable, and whenever I want to do a shift right, I just use that. So let's do another example. Okay, I have another one I've got typed in here. Shuffle XMM roll right by 1. Now a roll is similar to a shift, where everything goes to the right, but instead of what got kicked out going into nowhere land, it actually rolls around and gets put into the far left position. So it doesn't get lost. It just kind of wraps around back to the other side. So let's do that test. And I think I want to change this. Instead of retyping things, I'm just going to make test 2 do everything. And so there's loading the data, copy of the data. I'll use the same data every time. Instead of the shift right by 1, I'm going to do the roll right by 1. And let's compile that. And let's go to the debugger. Okay, here we are. Got us all set up here. Let's do step 1. Let's load our data. There's our data in XMM0. Step 2, make a copy of the data. Step 3, load in XMM2 our control, which is going to be the roll 1. Last step, perform the shuffle. Okay, if you look at XMM1, it's red. And if you compare it to XMM0, you should be able to see that the 0A that was on the far right is now on the far left. And all the other bytes got bumped down 1 position. That's a roll right 1. And that's that. Let's go back and do another one. Okay, you could probably see at the top, I've added 3 more rolls. Roll 8, roll right 8, roll right 4, roll right 2. Those are not very difficult to type in, by the way. It's actually a lot of copying and pasting and just kind of adjusting a little bit. And so let's do another test, and I guess this time I do want to make a test 3 because I'm going to do this a little bit differently. Let's put it here. Test 3. Let's say you have a number, hex number, dad, and let's say you do a move Q of that number into XMM0, and you move that in there. Now let's say you want to let's move into XMM1 our control to do a shift or a roll. Pshufb XMM roll right times 8 dot address. So what that's going to do, well, it hasn't done anything yet. Now let's run the Pshufb instruction on XMM0. You know, I'm kind of getting out of my pattern here. Let's do a move DQA XMM1 XMM0. So we'll make a copy. And then we'll put our control at XMM2 so we're consistent. And then let's also do the work on XMM1 using XMM2. So what that should do is take dad and roll it 8 bytes to the right, which should put it in the upper 8 bytes of the register. And now let's say you want to move a different number into RAX, Pshufb, and we're going to do a move Q, XMM0, RAX, and that should move that in there. And what I think what we might have now is XMM0 having an upper 8 bytes with dad and the lower 8 bytes with Pshufb. And let's say you want to access dad. Well, okay, so again, we need to move DQA XMM1, XMM0. Let's make a copy of our data, and let's issue the Pshufb XMM1, XMM2. And what that should do is that if we want to access, we can flip them. And this is kind of a useful thing. It's an example of how to do this. And let's just kind of look and see what it is if it's not clear. Let's stop. Oh, wait, before we go to the debugger, let's try to compile it. Oh, good. We got compiling. Okay, here we go. Step 1, put dad in RAX. And I got to drag my register window up. There at the top, dad is in RAX. Let's move it back down. And let's now move RAX into XMM0. There's dad. Let's make a copy of XMM0 into XMM1. And now let's move in our control buffer, which would be the roll right 8 bytes. And let's execute the instruction. Fantastic. We've now rolled dad. We basically swapped the upper 8 bytes with the lower 8 bytes, which is a real handy thing to be able to do. And now let's move Pshufb into RAX. There's Pshufb. And let's copy that into the XMM0. And okay, I see a little problem here. We lost dad. Hold on a minute here. Well, I don't think we lost dad. Hold on. Shoot, I don't remember. I went a little too quick. Let's start all over. think I got a little too excited. There's Dad. There's a copy of Dad. There's the shuffle. Oh, okay. So, all right. So we didn't lose. It was never there. All right. Then I copy over it, and I lose Dad because I make a copy of. All right. So, yeah, that's not so cool. Live on a video. Let's go back. Let's fix that a little bit. Okay, so that was a little embarrassing. Let's see if we can fix this. So we move Dad into XMM0. We make a copy of that in XMM1. We move in our control in XMM2. Then we shuffle it, which is moving it out to the upper 8 bytes. And that's in XMM1. Then we move Pshufb into RX, and we move Pshufb into XMM0, but XMM0 just has the, it's all full of, okay, so the upper 8 bytes of XMM0 are empty, and if we copy that over there, we lose Dad. All right, so that's, not so cool. Let's try this. Let's OR into XMM0 the contents of XMM1, and now that should combine them, and then now we'll make a copy to XMM1, and then let's try that. Let's see what we get. But before we run off to the debugger, let's compile it. Okay, now let's try that. Okay, here we go. Let's move Dad into REX. Let's move REX and XMO. There's Dad on the right. Let's make a copy of Dad. Let's put our control information into XMM2 again, and let's perform the shuffle. Boom, we rolled Dad to the upper 8 byte portion of the register. Now let's load Pshufb into REX. Let's load Pshufb into XMM0. And now let's OR 1 and 0 together, which now we have Pshufb and Dad together. Now let's make a copy of that into XMM1. So there's our data. And there's a copy of our data. Now let's perform the shuffle on XMM1. And you can see it flipped. It rolled. It did an 8 byte roll. So now you have a way to take the upper 8 bytes, swap them with the lower 8 bytes. And that is fantastic. I love this instruction. Well, now that we've got a few of these under our belt, I've actually typed in a whole bunch of different controls that could be used. And most of them aren't even tested. It's actually, once you see the pattern, it's actually kind of simple to type these in. I've got shift rights, 1, 2, 4, 8 bytes, shift left, 1, 2, 4, 8. I've got roll right, 1, 2, 4, 8, roll left, 1, 2, 4. I did do an 8 because roll left, right 8, and a roll left 8 are the same thing. I made dupes. Dupe B is the very first one we did. It's all full of zeros. It'll just take the first byte and duplicate it times 16. Dupe W just takes the first 2 bytes and duplicates them, and D is 4 bytes, and Q is 8 bytes. And I'm not going to go through them all and stumble through them. They're just, you can see how this Pshufb instruction can do multiple things, and it's not difficult. It's actually very sensible, and hats off to the creator of this instruction. I think he did a fantastic job. He made a great instruction. It's going to be very useful for SIMD, the algorithms I'll be trying to do in the future here. I've already used it for the base 64 version that I was writing, the decode. And thank you very much for this instruction. I hope everyone has a full feeling like they understand this instruction, that they can use it, and you have the ability to shuffle these bytes any way that you want, and it's great. So like and subscribe, appreciate it. Thanks for watching. See ya.